Good morning, friends. Today is Wednesday, September 30th. I'm going to review what we talked about in class yesterday. If you weren't in class yesterday, you might want to find a friend to work with today so that hopefully they can make things that are not clear a little bit more clear. Like I said, because this should feel like a review from yesterday. Yesterday, what we learned how to do is we learned how to solve equations where the variable is raised to the second power or the variable is squared. And we learned that in order to unsquare the variable, we use the square root. So if I wanted to solve for y, get y all by itself and figure out what is the value I could put in the place of y, I'm going to rewrite this equation here, y squared equals 49. I'm actually going to take the square root of both sides of the equation. And remember, if I do a mathematical operation to one side of the equation, I have to do the same mathematical operation to the other side of the equation in order to keep it balanced. So the square root of y squared, if you remember, y squared is just y times y. So the square root of y squared is y. And then this is where it gets a little tricky. If you know your perfect squares, you'll know that the square root of 49 is 7. So y equals 7. But what we talked about yesterday was that there is another solution, because y could also be negative 7. And the reason that y can be 7 or negative 7 is because if I take 7 times 7, I get 49. If I take negative 7 times negative 7, I also get 49. So both 7 and negative 7 can be put in the place of y to make that equation true. So this is an equation that has two different solutions. So the final thing I showed you yesterday was that sometimes mathematicians don't love to write a ton. We like to make things short and use symbols as much as possible. So a lot of mathematicians would write the answer to this equation as y is equal to plus or minus 7. This is just shorthand way of saying this, that the solution can be 7 or negative 7. I'm going to erase that so I have more room. When we come to an equation that where we're not going to have a perfect square, our solution is going to look a little different. So if I'm going to solve for n here, I've got n squared equals 10, so I'm going to take the square root of both sides of the equation. The square root of n squared is just n. And the square root of 10, though, 10 isn't a perfect square. So if I type that into my calculator, the square root of 10, I get big, long, irrational number. And so I could say, and I didn't show this yesterday in class, I could say that n is very close to 3.16 or negative 3.16. I could say that. I could say it's very close to that. But there's really no reason for me to estimate. And sometimes when we're doing real world problems, we might estimate. It really will depend on the type of problem we're trying to answer. And the more problems we answer, the more it will become clear when you want to estimate or when you want to keep an exact answer. But if I wanted to keep it as an exact answer, I would just keep this written in radical form. And I would say n is equal to the square root of 10 or the negative square root of 10. Or again, if I wanted to use shorthand and didn't want to write that 2 times, I could say n is equal to the positive or negative square root of 10. And so this is the exact answer if I kept it in radical form. And this is my approximate answer where I am rounding. So the last thing that I want to show you is that these types of equations that I'm showing you how to solve today are typically involved in questions like what you see here. So we have a square. The area of the square is 15 square inches. And what I want to know is, what is the length of each side? So the first thing you have to remind yourself is, where does the area of a square come from? Well, the side lengths of the square are all the same. So the area of the square comes from the side length times the side length. And because it's the same, I can say that that would be s squared. So I could write the equation, make sure you can see this. I could write the equation that s squared, the side length times the side length, is equal to 15 because the area of the square is 15. Well, then in order for me to find the actual length of the side, I would need to solve that equation. Well, we've been learning how to do that. So I would just take, let me write it. I would take the square root of both sides, and I would get the side length is equal to, and now I'm really going to think about what this is. Now I could put it in my calculator, and I could get an approximate answer, but today I'm going to keep this in the radical form so I have an exact answer. So I get the side length is equal to positive 15, the radical positive 15, or negative radical 15. But wait, one of those makes sense in this problem and one of them doesn't. Because this is a real world problem, while both of these answers satisfy this equation, they both can't be the side length of a square. The reason is that the side length of the square can't be negative. Length of something isn't going to be negative. So in this particular case, this one doesn't make sense. So while it's a solution to the equation, it doesn't make sense as an answer to the problem. So if I was then going to say, well, what is the side length of that square? Well, the side length of the square is radical 15. And it's okay, my friends. I know that looks like a funny number, but it's okay to say, well, that is the exact side length of the square, because it is. Now, if you feel like you really want to know what is that approximately, you can certainly do some thinking about that, or you can use your calculator. It's approximately 3.87 inches then. So we're talking inches since we've got the units of inches squared for the area. But to be honest, as we march forward in 8th grade, having your answer just be radical 15 is a totally fine answer. In fact, it's the exact right answer.